So good morning students. In this video we will be seeing an important problem in first unit, that is reactance diagram. So you will be given with a single line diagram. You have to convert all the reactances into per unit value and draw the reactance diagram. The methodology will be discussed in detail in this video. Kindly go through the video. Thank you.
In this video, we are going to solve problem number 3 in impedance reactance diagram. The given problem, draw an impedance and reactance diagram for the power system shown in the figure showing all the impedances in per unit. Choose the generator as base. The three-phase line-to-line ratings are given here. So the generator ratings are given 100 MVA, 20 kV and X equal to 9%. Transformer T1 90 MVA, 20 bar 200 kV, X equal to 15%. Transformer T2 90 MVA, 200 bar 20 kV, X equal to 20%. And motor 90 MVA, 18 kV and X equal to 8%. And the transmission line 200 kV, X equal to 120 ohm. So here the reactance value X for generator and transformer motor is given in percentage. So 9% in the sense it is 0.09 per unit. So you need to consider that as a per unit. And the single line diagram is also given here. Generator which is connected to a transformer 1, then transformer 1 is connected to a transmission line, then it is connected to transformer 2, and then finally it is connected to a motor. We can divide the single line diagram into various sections. So what are all the sections? The first section is generator and the low voltage side of the transformer, the primary of the transformer is section 1. Low voltage side of the transformer or primary of the transformer 1 is section 1, and the high voltage side of the transformer 1 and the transmission line, then transformer 2 high voltage side comes under section 2. Then low voltage side of the transformer T2 and the motor comes under section 3. So all these ratings are given in 3 phase. Okay, so now step 1, you need to find out the base value. Okay, or you need to assume the base value. So here in this problem it is specified that choose the base value from the generator side. So you need to select the generator value as a base value. So what are all the base values? You need to select the base MVA and base kV. Okay, so first we select the base MVA from the generator side. So generator base MVA is 100 MVA. So MVAB equal to 100 MVA. This remains same throughout the problem. And second, you need to find the base kV for all sections, okay, which we specified in the diagram. Section 1, section 2 and section 3, in all section you need to find out the base kV. First section, generator as a base, it is specified in the problem. So the generator rating can be taken as a base value, that is 20 kV can be taken as a base value for a generator section. Then section 2, which is high voltage side of the transformer T1 or the transmission line side. Here you need to find out the base kV on HT side of transformer T1. So here is a formula. Base kV on HT side of transformer T1 equal to base kV on LT side of transformer T1 into HT voltage rating divided by LT voltage rating of transformer T1. So base kV on LT voltage side, we know that is from section 1, the base kV is 20. So you can substitute the 20 over here and into the HT and LT voltage rating of a transformer T1, 20 bar 200. So 200 divided by 20 will be getting 200 kV as an answer. So this is for section 2. So section 2 you will be having 200 kV as a base kV. And section 3, that is low voltage side of your transformer T2 or low tension side, LT side of transformer T2. Formula is KVB, that is base kV on LT side of transformer T2 equal to base kV on HT side of transformer T2 into LT by HT, that is low tension side divided by high tension side. So you know the value of this one, that is base kV on HT side of transformer T2. Just now we found that 200 kV. So you can substitute that into the rating of the transformer T2. So 200 bar 20. So LT side is 20 divided by HT side is 200. So you'll be getting 20 kV as an answer. So these are the base kV for these three sections. Now step 3, we need to find the per unit value of all the components. Okay, so what are all the components present here? Generator, transformer T1, then transmission line, transformer T2 and motor. For all these 5 components, you need to find the per unit value, that is new per unit value you need to find. Okay, so for that we need to go for a formula. So first we start with the generator. So this formula is used to find out the new per unit value of an impedance. Okay, so Z per unit new equal to Z per unit volt into kVb volt divided by kVb new into MVAB new divided by MVAB old. So this old represent given value. Okay, and the new value represents a base value here. So you need to substitute Z per unit volt, that means Z per unit given. So given value for the generator is 9%, so 0.09 you need to substitute. Since it is a reactance, you can substitute with J 0.09 into kVb old is given. So given value for generator section, so generator is under section 1. So given value of kV for the generator is 20 kV divided by kVb new. The new value is here base value. So base value under section 1 is 20. So 20 divided by 20 the whole square into MVAB new, that is base MVAB under section 1 is 100 MVA. The MVAB remains same throughout the problem. So 100 MVA divided by MVAB old is nothing but your given value. So given value is 100 divided by 100. So you can simplify this, you will be getting the same answer, J.09 per unit. So like that you can find out the per unit impedance for all the components. So second component is a transformer T1. Now transformer T1 under section 1, understand it clearly, under section 1 transformer T1 LT side is connected. So you need to take the LT side value, that is 20 kV you need to consider. So the same formula you are applying here, Z per unit volt, the given value is 15% and the given kV is 20 since it is LT side. Okay, and the base kV is LT side, that is section 1 kV, that is your 20 again, and MVAB base is 100, you know that, and divided by MVAB old, that is given value is 90 MVA, that is given in the problem. So if you simplify, you will be getting J.17 per unit. The next section is your transmission line. The transmission line is located under section 2. So you will be having a base value under section 2. Okay, so section 2 having 200 kV as base value and MVA is 100. And for transmission line, the value of X is given in ohm, 120 ohm. That means actual value of X is given. So you need to go for this formula for transmission line alone. Okay, all other equipment, that is motor, transformer and generator, you can go for the previous formula. And this formula is applicable only for transmission line and cables. Z per unit new equal to Z actual into MVAB new, that is base value. New means base, divided by KVB new the whole square. Actual value is given here, that is in ohm 120 into 100, that is base MVA, which is common throughout the problem, divided by the base KV 200 whole square, that gives you 0.3 per unit. Now we move on to the next one, that is transformer T2. So transformer T2 under section 2 itself, the transformer T2 high voltage side is connected, that is 200 voltage kV side is connected. So you can consider this 200 kV to find out the Z per unit new for the transformer. So Z per unit new equal to Z per unit old, that is given value 20%, J.2, then KVB old, that is given 200 here, divided by new value is also 200 under section 2 into new value is a base value 100 divided by 90 MVA, which is given in the transformer T2. You will be getting J.22 per unit. Now the next section is a motor. So under motor section 3, your KVB new, that is base KV is 20 kV. You can apply this formula. You can substitute the value. The motor given impedance is 8%, that is 0.08 per unit into given value is 18 kV divided by the base value is 20 into base value 100 MVA divided by given MVA is 90. So if you can substitute, you'll be getting J.07 per unit. Okay, now in step 4, you need to draw the impedance and reactance diagram. First, we'll draw the impedance diagram. So from the single line diagram, first component is a generator. So you need to draw a generator, induced EMF with the reactance. Then second component is a transformer. You need to draw a transformer reactance. Then third one is a line reactance. Then transformer 2 reactance. Then followed by the motor reactance with the motor back EMF with the motor induced EMF. This is how you need to draw the impedance diagram. Then you need to substitute all the values what we found for all the components. The per unit value for the generator is 0.09. Then for transformer 1 it's 0.17. For line it's 0.3. For transformer 2 it's 0.22. Then for motor it's 0.07. This is how you need to represent an impedance diagram from the single line diagram. The procedure to draw the reactance diagram, how to draw the reactance diagram, it is given in the description box. You can refer the link and you can learn how to draw the reactance diagram and impedance diagram from the single line diagram. So after drawing this impedance diagram, now the reactance diagram, so both this reactance diagram also remains same as your impedance diagram, since here there is no resistor and load present in the single line diagram. All the values given here is only reactance, there is no resistance. Okay, so both the impedance diagram and reactance diagram will be a similar one.
So in this video we saw about the method of drawing reactance diagram, and in the next video we will be seeing about bus incidence matrix. Thank you so much.